Hello everyone, we are Group 6. Today our topic is predicting student dropout risk, balancing performance and explainability. Why student dropout risk prediction is important. Student dropout can affect academic success. If school discover the problem too late, students may already be far behind, or they may have already decided to leave school. Therefore, schools need an early warning system. Machine learning can help because it can use student data to identify possible risk patterns earlier. For example, a student with a low midterm score and many absences may need more attention. The code on this slide shows the first step on the program. This slide loads the student dropout dataset into Python. After the data is loaded, we can start processing the data, training models, and comparing the results. So this project starts from student data and uses machine learning to support earlier insertion. This slide explains the main objective of our project. The main goal is to build a machine learning model that predict dropout risks. There are two possible prediction results. High risk is represented by 1. Low risk is represented by 0. The research question is: which model provides the best balance between performance and explainability? In the code, we separate the dataset into input feature and the target variable. Here X means the input factor used for prediction. It includes midterm score, absences, admission type, and gender. The variable Y is the target variable, which means the answer the model wants to predict. In simple words, the model uses student information to predict whether the student is high risk or low risk. There are 4 input features and 1 target variable. The first feature is midterm score. It is a numerical feature and represents the student's midterm exam score. The second feature is absences. It also a numerical feature and represents the number of absences. The third feature is admission type. It is a categorical feature and represents the student admission pathway. The fourth feature is gender. It is also a categorical feature. The target variable is dropout risk. In the program, the input feature and target variable is selected like this. The program also checks the data set by using. This is help us check the number of data records, the distribution of dropout rates, and the first few rows of the dataset. This step is important because before training a model, we need to understand what kind of data we are using.
The data preprocessing pipeline. Because the dataset contains different types of features, we need different preprocessing methods. For numerical features such as midterm score and absences, we use standard scalar. The purpose of standard scalar is to normalize the data range. For example, midterm score may range from 0 to 100, while absence may range from 0 to 10. If we don't scale the data, some methods may be affected by the different feature scales. This is especially important for models such as KNN and SVM because they are sensitive to distance and boundaries. For categorical features such as admission type and gender, we use one-hot encoder. One-hot encoder converts categories into binary values. This is important because categorical data shouldn't be treated as order numbers. For example, admission type is only a category. It doesn't mean that one admission pathway is greater than another pathway. So this preprocessing step helps the model understand the data correctly. How the dataset is divided into a training set and a testing set. The training set is used to train the models. The testing set is used to evaluate how well the models perform on unseen data. In this project, 67% of the data is used for training and 33% is used for testing. The parameter testing size means that 33% of the data is used for testing. The parameter random state keeps the data split fixed so the result can be repeated. The parameter stratify keeps the class distribution balanced in both the training set and the testing set. This makes the evaluation more fair and reliable. How preprocessing is implemented in the program. The numerical features are the first row on the left, and the categorical features are the second row on left. Then the program uses column transformer to apply different preprocessing methods to different columns. This means that numerical features are processed by standard scalar and categorical features are processed by one-hot encode. And this slide is connected to the previous preprocessing slide. The previous slide explained the concept. And this slide shows how the concept is written in Python code. This pre-processing step is also important for fair model comparison because all 4 models use the same pre-processing pipeline.
This slide introduces the full machine learning model comparison in the project. The full model are KMM, Loess regression, SVM, and the decision tree. KMM means the similar student may have a similar outcome. Loess regression predicts the probability that a student belongs to the high-risk group. SVM found the best boundary between hierarchy-based decisions. In the program, these 4 models are stored in a dictionary. This makes it easier to train and compare all models. You see the same process. The key idea here is fun comparison. Only the model changes while the data sets, train tests spread, and pre-processing pipelines stay the same. This slide explains KNN and Loess regression. First, KNN stands for K-nearest neighbor. KNN predicts a student dropout risk by looking at similar students. In the code we use K-neighbor classifier and uncle neighbor equals 5. This means the model looks at the 5 nearest neighbors before making a prediction. The advantage for KNN is that it is easy to understand. However, its disadvantage is the immense becomes slow when the data set becomes large because it needs to calculate distances. The second model is Loess regression. Loess regression predicts the probability of dropout risk. Its advantage is that it is fast and stable. It is also useful as a baseline model. However, Loess regression works best when the relationship between features and the target is more linear. This slide explains SVM and the decision tree. SVM stands for support vector machine. The main idea of SVM is to find the best train defense classes. In the project, SVM tried to separate high-risk students and low-risk students. SVM have strong classification ability and can handle more complex boundaries. However, it is more difficult to explain. There is a problem in this project because the model may be used by school counselors or non-tech users. The second model is the decision tree. The decision tree uses rules to make prediction. For example, it may check whether the meter score is low and whether the number of assassins is high. The advantage of the decision tree is it is easy to understand and has transparent row. The pomerodas makes discovery limit the depth of the tree. This helps prevent the tree from becoming too complex and keep the ruler easy to explain.
That's why accuracy alone is not enough. Accuracy means the overall correct prediction rate. For example, if there are 1,000 students and the model predicts 950 students correctly, the accuracy is 95%. However, in dropout risk prediction, accuracy can be misleading. Suppose there are 1,000 students and only 50 students are high risk. If the model predicts everyone as low risk, it can still get 95% accuracy. But this model misses all 50 high-risk students. This is not useful for schools because the purpose of this project is to identify students who need support. Therefore, we also use precision record and F1 score. Precision shows how many predict high-risk students are truly high risk. Recall shows how many high-risk students are successful found. F1 scores balance precision and recall. This project, recall is especially important because we want to avoid missing students who really need help. The model conversion result. The evaluation results are stored in table by using this. The table compares the four models using accuracy, precision, recall, and F1 scores. From the result, KNN has an accuracy of 0.6667 and a recall of 0.2812. Logistic regressions has an accuracy of 0.6970 and a recall of 0.4688. SVN has the highest accuracy 0.7172, but the record is 0.4062. Decision tree also has an accuracy of 0.7172 and its record is 0.6250. This means decision trees performs we have and finds more truly high-risk students compared with the other models. Decision trees also has the highest F1 scores 0.5882. Also, based on both performance and practical use, decision trees is a strong choice. This result support the final model choose in next slide. Why decision tree is chosen. Decision trees is selected because it provides a good balance between performance and explainability. In terms of performance, it has complexity, accuracy, and strong recall. According to the result table, decision trees has the same accuracy as SVM, but it has a higher recall and F1 score. This is important because we want to find students who are truly high risk. In terms of explainability, decision trees provide human-readable rules. These rules are easier for consumers to understand. The code on the slide shows the pipeline. This means every model uses the same processing steps before training. Because all models use the same pipeline, the compression is far. Decision trees can also contain prediction resort to score intervention. For example, a low score can lead to academic trolling. High balance can lead to counseling support. And specific admission pathway can lead to early orientation programs. Therefore, decision trees is not only useful for prediction, but also used for explaining the reason behind the prediction.
为什么你们最后选择决策树作为这种模式
？We chose decision tree because it provides a good balance between performance and explainability.
为什么在这个专案中答案正确率是不够的
？This can be misleading when the data set is imbalanced. For example, if most students are low risk, a module can predict everyone a low still and still get high accuracy.